Alright guys, so this is section 8.4, and these are just some kind of random proportionality theorems among triangles. Okay, so there's three here, and if you know all three theorems, these are not difficult. They're just setting up a proportion and solving them. So on your note card for your test, this is definitely something, these three theorems are definitely something I'd write down. Okay, so prerequisite skills, guys, we've been solving ratios and proportions. We should be able to solve this one too. So cross multiply 3 times 2x, that's going to be equal to 5. Don't forget you have to put this x minus 1 in parentheses. Okay, now because it's in parentheses, we have to distribute. So 3 times 2x is 6x equals 5x minus 5. Minus 5x on both sides. I get x is equal to negative 5. All right, so here's the first of the three proportionality theorems, and this one kind of has, this is a pair because the converse of it is also true. Remember, the converse is when we flip the hypothesis and the conclusion. So on both of these, you have a triangle, but you have two parallel sides of these triangles, okay? So if a line is parallel to one side of the triangle, it intersects the other two sides, then it divides the two sides proportionately. I misspelled, but that's okay. Okay, so if these two are parallel, so if QS is parallel to TU, okay, that means it cuts this proportionally. Okay, so that means that RT over RU is going to be equal to TQ over S. Okay, or if it helps you, if this is X, Y, Z, and I don't know, R, okay, you could write this as X over Y equals Z over R, okay? If all these letters confuse you, think of it this way, okay? Likewise, if I know that this and this is proportionate to this over this, then I could say, if a line divides two sides of a triangle proportionately, which is what I just said, then it divides, then it is parallel to the third side. So all I'm doing is flip this. Okay, so if I know that RT over RU is equal to QT over SU, okay, then that means that these two lines have to be parallel. So QS is parallel to T. Okay, it just goes both ways. All right, so let's look at an example. Okay, find the length of RQ, which is here. Okay, first thing I want to do is I notice these two sides are parallel. Okay, so that means that it cuts them proportionally. So this over this is going to equal this over this. Okay, so I can set up a proportion. So 4 over x is equal to 6 over 9. Okay, then I'm going to solve, cross multiply and solve. So 6x equals 4 times 9. 6x is equal to 36. X then is 6. Okay, I want you to go ahead and pause this video. Try to do this one on your own. You're going to use that same exact theorem. All right, so when you set this up, you should have just made this x because that's what you don't know. It's what you're trying to find. So x over 10 is equal to 12 over 8. There's several correct ways you can set this up. When you do, you should get x equals 15. Okay, let's look at the converse of this. So it says on the shoe rack, BA is 33. I'm going to go ahead and 33. CB is 27. CD is 44. and DE is 25. Okay, explain why the shelf is not parallel to the floor. Okay, so for this to be parallel, these proportions have to be the same. Okay, if the proportions are not the same, then it's not going to be parallel. So we need to check to see if they are. Okay, so I want to check, is 27 over 44 equal to 33 over 25? Okay, I did this in this proportion, this and this proportion. Okay, now if I cross multiply these, I get 20 times 25. Is that equal to 33 times 44? Well, let me check. So 27 times 25, it's 675. Equals 33 times 44, not equal to 1452. Okay, so not parallel by the converse of the triangle proportionality theorem. Okay, the three parallel lines theorem. Okay, well, obviously you need three parallel lines. Okay, so in this case, parallel, parallel, parallel. Now, when you have three parallel lines, you cut it, or you, I guess, separate it into four parts. So like this part, this part, this part, and this part are all separate. Okay, and what happens is if these three lines are parallel, it cuts those four parts to where they make a perfect proportion. Okay, so let's look at this. Okay, so in this diagram, angles 1, 2, and 3 are congruent. Well, those are all corresponding angles, which means these three lines have to be parallel. Okay, so because they're parallel, I want to find the four pieces that it cuts. So like this piece and this piece are 1, those are corresponding. This piece and this piece are 1, those are corresponding. Okay, so I want to find the distance HF, this whole thing. But before I find that, I have to find this piece right here. So I can set a proportion. Because all three of these are parallel, I can set a proportion that 120 is to 150 as x is to 300. Okay, then I cross multiply. So 150x equals 120 over 300 times 300. So this is a big number, 36,000. Back to 150. It's 240. This piece right here is 240 yards. Okay, well notice it says find the distance HF, which is this whole distance here. So I would have to add these two pieces. So HF is equal to 120 plus 240. So HF then is, on top of this 240, is 360. Don't forget the units. All right, I want you to go ahead, pause this now. I want you to try to do this on your own. Okay, and then we'll go over it. All right, so hopefully you worked through this. Okay, you set it up proportionally. Okay, you should get this small piece here is 14, and then it asks for DF, so you would add the 35 plus 14, which would give you 49. All right, so this is the last of the three theorems. It's the triangle angle bisector theorem. Okay, now, if a ray bisects an angle of a triangle, okay, meaning that it cuts it into two smaller congruent angles. So like here, this bisects this angle because these two angles are congruent, okay? This has to happen in order to use this theorem. Okay, so if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Okay, so when we divide this angle, what we do is we cut it into like 4 pieces. Okay, and just like everything else, we can set those pieces up and make a ratio, make a proportion, and solve. Okay, so if I look at this, okay, I know this bisects this angle because these two are congruent. Okay, so I can use the angle bisector theorem. Okay, now when I do that, the ratio of those two sides are going to equal the ratio of these two sides. Okay, now the hardest part here is we don't know this side and this is already x. So we can't make this x because this is already x. So think about this. If I have this here and I know this whole thing is 15. Okay, let's just pretend, I don't know, this is 10. Okay, we'll put numbers to it first. Okay, if this is 10, then this would have to be 5 because this would be 15 minus 10. Okay, with numbers, this isn't difficult. The problem is we don't have numbers. We have an x. This is x. Okay, well, if this piece is x, I'm talking about this line right here, guys. If this is x, this is still going to be 15 minus x. Okay, so this is 15 minus x. Now I can set up a proportion. So I could say 7 is to 13 as 15 minus x is to x. Okay, I want the pieces of the triangle, not the whole thing. Okay, so cross multiply, so 13, 15 minus x is equal to 7 times x. 13 times 15 is 195 minus 13x is equal to 7x. Is equal to 20x. Seven five would be your answer. All right, I want you to pause this video, do B on your own, which is much easier than A, okay, and then unpause it and check your answer. All right, on this one, okay, you should have set up a proportion and you should have gotten y equals 27. Okay, it's the same theorem we just used, the triangle angle bisector theorem. All right, let's look at our last example for this video. Okay, we kind of cheat because it says using the triangle proportionality theorem. Okay, so for these to be proportional, or if these are proportional, then these will be parallel. Okay, if these are not proportional, these will not be parallel. Okay, so what I need to do is to check to see if these have the same ratio. Oh, thicker color. So, is 90 over 72, is that equal to, and I'm going to put a question mark, 50 over 40? Okay, if it is, they're parallel. If it's not, it's not. So, is 90 times 40 equal to 50 times 72? I need to put a question mark. 40 is 3,600. 72 times 50 is also 3,600. So yes, they're proportional, which means that PS is parallel to Q.